Okay, Unit 3FA, the first one, Skewed Lines. Now, I get this all the time. Why the F do I need to learn how to find the shortest distance for a skewed line? Okay, here's the best scenario I can give you, because it's actually legitimately. You're drawing a roof to a house. You have two different angles where your eaves and everything are coming in lining up. And then you have your ridge line that connects between those two. You need to know what that distance is if you're going to be cutting the material that's going to go between it. So you need to know these kind of things. You need to know what is the shortest distance between those two lines, because typically that is where your ridge line is going to be, and that's where everything connects and goes together. You also need to know the shortest distance sometimes between skewed lines when you're drilling for plumbing and you've got lines running through and you need to connect, or you need to make sure you're not touching, that they're at a specific distance. So instead of like really finding the shortest distance, you want to get them as close as you possibly can legally without them touching and doing something bad. Like for an example, you don't want electrical anywhere near gas, because that would be really bad. Those two go together and there's a spark and it blows up and it kills a lot of people. We don't want that. So there's some reasons why we need to know the shortest distance specifically between skewed lines, because you may have, for an example, the gas line is down 2 foot and then maybe your electrical line down is only a foot, and when they have to spend X amount of distance away from each other, we need to find those kind of things. So in this one, we're going to find the shortest distance between these lines here. Okay? Excuse me. So step one is I'm going to go ahead and line this up, and I'm going to transfer measurements real quick. Dang it. There he goes. That's a little better. Dang it. Darn it. My wardrobe is working against me today. Okay. So 4 is already lightly connected for you. Let's connect 2. Connect 3. Connect 1. Okay. Now we want to draw a perpendicular line. So we want it to come from here out perpendicular through point 1. The way you do that, we take our triangle. Any of them, it doesn't really matter. And so I'm going to keep that edge straight going along that line so I can get that perpendicular line, and I'm just going to keep moving it over until it hits 1. So this edge is running straight across that line 1, 2, and the perpendicular edge for it now goes through point 1. So that's how you find that line that we need to use. And then once you've done that, I'm just going to turn it around. Actually, let's not turn it around. Let's do it this way. There we go, because what I'm trying to do is get it so I can get those 90-degree angles. So I can use my triangle for that. There. So I should now have a perfect 90-degree, and if you're not sure that you're getting that perfect perpendicular, if you've got it lined up, line a triangle up on it and you'll see your corners, you'll see that they've actually lined up. So if you're not 100% sure and you're not trusting yourself, use that as your point of reference. Okay, and let's go ahead and find our farthest distance we need to go out. So we know we need to know measurement A, measurement B. Oops, dang it, I hate it when I do that. Sorry guys. Okay, there we go. Sorry. So we're going to find B, that distance there, and transfer it to over here. So that becomes B, and transfer A. Find A. Same thing. There's our A. So my farthest distance out will be to here. Yeah. 1, 2, 3, and 4. Play a game, connect the dots, remember? So let's find point 1, 2. So I know that point 1, 2 falls along here, and 1, 2 falls in the distance A. So here's 1 and 2. So that would become 1 and 2. Now I would need to find, okay, let's find 3, 4. I need to fix the answer keys. I have those numbers off because the 3 is actually here 4. So let's find 4. 4, if I look at it, and I know it's the same distance, it comes at the A. Because if I bring that over here, it's just going to hit the A. So we find 4. It would help if I had drawn down A, wouldn't it? There we go. Okay. 4 and A meet here. Then we need to find where does 3. 3 is on B. Here's 3, and that goes back to here. That becomes point 3. So that's now the line. Why is this important? Because we're going to make this perpendicular to find the shortest distance. So we now have 3, 4. We want perpendicular that fits here. So I'm actually going to untape it for right now and make it a little easier so I can move it more to the screen. Come on. So we now want a line that's perpendicular that hits that 1, 2, but perpendicular to that line 3, 4 to get that actual shortest distance. And this is not cooperating with me. Sorry guys. Because it's hard to get it in the frame here and deal with my little small drafting table here. Okay, so here's that point 1, 2. I take my triangle until I line this bottom straight edge lined up with that. Lined up with that. Come on, cooperate. That gives us our 90-degree angle. Now, believe it or not, to find and draw the shortest distance here, I'm actually going to label this just because it's easier for me. I find it's always easier if I label my points B and A. So now we need those points to come back over here. So I do that same thing I had a minute ago. Make sure it's lined up with my straight edge. Tape it down. Bring that A to over here. Gives me A. Repeat that perpendicular process because we know AB is perfectly 90 to each other, right? And I'm going to have to turn this at a funny angle to get it in here. There. So I'm lining that up along this edge here. I'll get that 90-degree angle with my triangle. Dang it, don't let it move on you. Be careful, because it will move on you. So that gives me B. Because again, that whole 90 degrees, this has got to be 90. There's B, and there's A. Then we need to repeat that whole process. We need to bring them down. Up. And up, tape it down. Fine. It's not wanting to cooperate collaborate with me, so I'll just do it from the top here. Find A, bring it down, find B, bring it down, that's your B, that's your A. Now, this right here is the actual shortest distance. So then what you're going to do is you're going to come here and you're going to take your engineering scale and you're going to lay it on here and you're going to measure it, and then you're going to write down and tell me what that measurement is. So we know what the shortest distance is. We know what the actual real shortest distance is. That's like the true length, right? And then we know that that is where they would connect here. So if I was drawing those lines and I needed to know where they cross over, etc., they're there. Of course, you need to always make sure, go in, sorry, and don't forget to fill out your title block. Go over the same use and state, put the date, go over drawing 3A, go over skewed lines, and then of course put your name, and then you turn in for grading. Now let's go do the last of the skewed lines. 3FB, skewed lines, so we're going to finish this one. This one you're going to use your engineering scale again, but at the end you're going to make it equals to 5 feet. So for an example, if it ended up being 1.5 inches long, that would be 5 feet, 7.5 feet, all right? So just some basic math there. So let's line this up and let's start connecting some of our lines together first. There he goes. Tape it so it doesn't move on us. Oh, it moved. Dang it. Come on, come on, come on. There it goes. And what it is we're trying to find the shortest distance between these angles and lines. So of course, step one is going to be to connect everything. So I've drawn everything up to here because this is going to give us like the edge view, our line. So what we're going to do now is we're going to come over here and we're going to find the actual like real triangle of this here. And then once we find that triangle, we'll be able to bring that over and find the shortest distance to get the shortest distance of it. So we'll start off with a couple things that we know we need to find. We know we need to find distance A, which is our shortest distance, all the way to our longest distance here, which is going to be, this should be, because from here to here is our A. From there to there would be our D. Our next shortest distance would be the C. And then the next one would be the B. That distance there. So I'm just finding out what those are so that I can draw them here. All right, so we're going to draw a line parallel to 5, 6, 3, 1. So line it up, tape it down. That way I get my perpendicular lines from my farthest points out here. Go ahead and transfer my farthest distance, which I know happens to be the D. Just from here to there. So I mark it. D, we're just going to go backwards. Let's find C. C. B, and then A. Okay. Transfer our perpendicular measurements. You'll notice now 7 lines up to here. Come over here. Bring 8 out. I've brought 6 out.
That was funny. Yeah. Thank you, Carrie. But it's
Okay.
she probably has extras, but it's kind of hard. So you'll just probably like sit down.
Alright, let's just find point 7, 8. Let's draw 7, 8 first. So I know 7's along this line, and I know the distance that it comes to, if I look here, is the A. 7. And then 8. 8 is on here. 8 comes out to the farthest distance, the D. 8. All right, let's find 5, 6. Here's 5. 5 comes out to the distance of, what is that? Yeah, that would be this distance here, the C. So 5, 5, C. 5, and then 6. Where's 6? There's 6. 6 comes out to the second farthest, which is the B. I now have the triangle of those. Remember, we're trying to find the shortest distance, so we're not really worried about finding that triangle. We don't have to write it down. I haven't been asked for that, but that's what we just found. Now we need to find the shortest distance, and we're going to find that over here.